Good morning, everyone.
Good morning.
Good morning.
Morning,
Aarti.
ma'am.
Hello, everyone. Good morning. Dear authors and invited guests, welcome to the technical session 5B. I, Aarti Mohan, and the session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it's my great pleasure to welcome you all to the third World Conference on Information Systems for Business Management ISBM 2024, Bangkok, Thailand. The third edition of this conference is being organized in a hybrid mode. The physical event is being organized today in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th September 2024. I hope you all gonna be enjoying this knowledgeable session and interactive session throughout the day. In this session, we have 6 presentations. Each presenters will be given 12 minutes for the presentation and 3 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants to stay connected with us till the closing remarks. If you have any sort of queries, then you can write it to me in the chat box. Just before we get started with our session, I would like to introduce you all to the chair of this session, Dr. Varsha Damodar Jadhav. She is currently working as an assistant professor in artificial intelligence and data science department of Vishwakarma Institute of Information Technology, Pune, India. She has 19 plus years of experience in teaching. She is a member of Board of Studies for Artificial Intelligence and Data Science Department at Vishwakarma Institute of Technology, Pune. It's a great pleasure to have you on board with us, ma'am.
Thank you. Thank you very much, Aarti.
Moving on to, I would like to now start with our papers. Moving on to our first presenter, I would request the presenter to start presenting her paper on the paper title, A Novel CNN-Based Approach for Cervix Cancer Type Classification. Dear presenter, could you please proceed? Could you please start with your presentation? Moving on to our next presenter. Lakshmi RR, I would request the presenter to present her paper on AI assist for crop recommendation and precise fertigation.
Thank you for the introduction. Can you hear me?
Yes, ma'am.
Yes, yes,
Thank
yes, we can hear.
I guess the PPT is being shared.
Yes, ma'am, it's
Ye-
visible.
Yes, yes, it's visible.
Yes, thank you so much. Good morning, all. I'm here to present a part of my research work titled AI Assist for Crop Recommendation and Precise Fertigation. We are from Amrita School of Engineering, Amrita Vishwavidyapeetham, Coimbatore, Tamil Nadu, India. Just want to give a brief introduction uh, why we have chosen this. The main reason is we have concentrated on to one of the main work that happens in our local area, which is agriculture. It is playing an important role, giving employment, economic growth, sustainable food, and giving more options for industrial development. Though just saying these words, a particular output can be made only if the crops are given proper fertilizers, mainly using nitrogen, phosphorus, and potassium. We are just concentrating onto this one. Why? Because this is a backbone where we are focusing on to the development of on AISs. But normally over here, the farmers are not well educated. They just apply the very much cost-effective agrochemicals. But greater application, they are thinking like they'll be getting more yield. But on the other hand, it affects the ecological environment and also is harmful for the humans. With that, we are focusing on the agriculture 4.0, where we are going with a planned, predictive, and a productive environment that makes use of digital technology, and it is possible, very much successful, if we incorporate intelligent assistance. Keeping that in mind, we are seeing our objective to develop an intelligent farmer assistant through a web-based platform that recommends a suitable crop based on the NPK values and the environmental condition based on the machine learning model. So just like that, we cannot randomly choose a machine learning model. Based on the literature survey, we have picked three models, and a comparative analysis will be done, and the best model will be selected among the decision trees, random forest, and XGBoost models. And in addition to that, our model will provide precise fertigation, will give the instruction, and will give an information to the farmers also regarding the status of fertigation. So these will be done automated with the help of a microcontroller. So this is the representation of our system where we have a website, and on the background, we are having an ML-based crop recommendation system that accepts the soil and environmental condition, will say which is the best crop suitable for that soil, that will be indicated to the farmers through the website, which is a friend end. And in connection to the crop, the recommended crop, back end table will be there. That gives an information about the fertilization stages and then duration of each stage, the number of days required for giving the fertilization. And these things will also be given to the farmer so that he can start preparing the fertilizations. And according to that, yeah, this background can be given, can be one of the instructors to provide information to the microcontroller by calculating the time in which the valve is to be opened so that the fertilization is required. So the microcontroller will give the action signals to the valve in order to provide the fertilization. Moving on to the fertilization part, the precise irrigation part, we are concentrating on giving two types of fertilization, which will be filled in two different tanks mixed with water. Based on the solubility, the liters will be calculated. So upon the instruction from the microcontroller, enough fertilization will be going through the pipe and will be fed to the drip irrigation channel. And this is controlled through the solenoid valve that is instructed from the Raspberry Pi. In addition to that, the flow is also calculated so that correct amount of fertilization is fed so that it does not make the soil to be very much damaged. So first thing is like to have a machine learning model. For that, a backbone of the machine learning model is data. So we have collected the data from Kaggle, an open source environment, where we have 2,200 instances with different categories like rice, maize, pomegranate, banana, mango, watermelon, etc. And those are taken as a target, which means it's a classification category. And the input attributes are NPK values, temperature, humidity, rainfall, and pH. So this will be given as the input. So this is one of the a sample of the input, how it looks like for rice. Now the data as such cannot be taken. Why? Because like we found like many NaN values are there, zero values are there, which has to be removed. That is also incomplete. That will affect the accuracy of the model. So pre-processing is done, and then the values are normalized using min-max scaler. Then for the test and train, a sample is created in the ratio 80:20, which means that 80% of the domain data is used for training, and the remaining 20 is used for the testing purpose. And based on this specifications, the decision tree, random forest, and extreme boost models were trained and then tested using the test model. And based on that, we have obtained the confusion matrix for the decision tree as shown here for the random forest and for the XG boost. And this data, these three data are used for calculating the precision recall F1 score for each of the 22 classes. And according to that, we have got the best model to be a random forest. Summary is given over here. And in order to double check for the overfitting or the underfitting issue, we've just calculated the accuracy with the training as well as the testing data. And this is the result for that. And we have seen that with the random forest, it has given better accuracy. And the ratio between the training and testing is also almost same, which means that among these three models, the random forest will be the best one for doing the classification. So this is background in order to recommend which crop is suitable based on the soil parameter as well as the environmental condition. So in the front end, the farmer just need to feed the values based on the required data, and then he can go with the recommendation. And the site will be for this input, we have found that the best crop is watermelon. And according to that, in the front panel, in the front platform itself, the details about the fertilization will be displayed to the farmer. And also the schedule also in how many stages the fertigation must be applied. For each stage, what will be the number of days required and what level of fertigation is required. So according to this crop, 4-stage application is required. In the crop establishment stage, first 10 days duration, the fertigation must be given. So the two fertilizers are, and one is NPK, another one is urea. The kilogram per hectare values are given. In addition to that, from the data sheet, the solubility must be calculated, which will allow the farmers to mix the required amount of fertilizer along with the water during the drip irrigation. So based on that, we can calculate each day requirement, how much fertilization is required, and this will be the reference for the flow sensor. So flow sensor will see whether the each day requirement is met, and that value, based on that, it will try to open and close the valve. So this is a flow chart shows like how the microcontroller will be controlling the auto fertigation part. It will see how many phases are required from the front end, uh, and then the number of days corresponding to each phase, and how much fertilization amount is required. All these values will be initiated to 0. And then after calculating the fertilizer requirement in liters, the solenoid will be turned on and the flow sensor will try to calculate the value. Once it reaches the required the amount, the solenoid will be turned off. It will see whether this will be repeated for n number of days till the required day is met. Once the day is met, it will wait for the next stage to happen. So this will go on till the number of phases are completed. So for this condition, for 4 phases, this entire process will be happening. So this auto irrigation is done through a solenoid valve, which will be opening and controlling the flow of fertilization. And then there's a flow sensor to check whether enough amount of fertilizer is being fed to the crops. It has been drain of the system, which is Raspberry Pi. And for powering up the solenoid, we need a 5-volt supply. And then for turning on and off the supply, we are using 5-volt relay. And the drip irrigation pipe which we have selected is half-inch drip irrigation pipe. This is a front end, the status that is shown to the farmers regarding the fertilization stage. So the first part shows that the phase 1 is running, where 4 phases are there. The remaining phases are yet to be completed. The second figure shows that the third phase is running and the fourth phase is pending to be completed. So a miniature version of this hardware was implemented to check whether everything is done properly based on the amount of fertilizer collected, and the number of days required is met, and the number of phases are met. Once that is done, we have checked for different crops also, and the recommended crop was also matching with the expected value, and it was also matching with the fertilization duration also. Once this was done, we have been extended. The same work has been extended to one of our small near our village, and that is also found to be very much successful. So these are the two sets. This diagram shows that the first stage of irrigation is being done. So conclusion is like three models were selected from the literature survey that was seen to be giving a good accuracy. Based on that, the best model, random forest, was selected, and the fertigation module, hardware of that was developed, and different tests were conducted to check whether the fertigation module is giving the required output. And based on that, a very much user-friendly platform has been developed, and that was also like a feedback has been collected from the farmer. They were saying that though they don't have any that much technical knowledge, they were able to somehow keep up with this one. It was very helpful for them. So, and also we have done this for different crops also, and found that the model which we have selected is giving the better answer. These are the references used. Thank you.
Thank you, ma'am. Thank you so much for your presentation. Ma'am,
Thank you so
you
much.
have any questions?
Yes, yes, please. Yes, Dr. Lakshmi, very good
Yeah.
presentation, and the work is also very nice.
Thank you. Thank you.
Yes, yes. My question is that when the farmers are having illiteracy about the technical knowledge where AI
Yes.
assistant system is being used, so what different steps you have carried out to make them aware of all this technology?
Yeah, the whole work started actually 3 years back. Like the main vegetation, one of the main vegetation is tomato. So we were trying to make a model, a deep learning model, to check whether the tomato plants are of good health or not. So we asked like, what is the condition of tomato plants, and they were saying like, few plants are having issue. So they were just showing us the leaves, and then we were able to find that some spots were there. And I asked like, what disease is this? So they were saying like, it's diseased only, but we don't know what disease is that. So I asked them, how did you treat them? So they were saying like, a person from agricultural university comes to them, and then they will say that you just apply this one. So every time they're completely dependent on these people. So
Okay,
we
so
understood that technically they're very weak. And also the amount of fertilizers that they apply is very huge.
so any
And
kind
it
of
is,
workshops like group discussions with the farmers should be carried out
yes,
in this
yes.
case.
Yes,
Mm.
yes, yes. We have done discussions, and then we have had a meeting with those people who were coming and then treating their plants also. So based on that knowledge, like we told them like, not much in excess should be applied. Why? Because like they were saying like, after one harvest, they are in a position to leave the land empty for some time. If they are using the
Okay.
same land,
My,
they're
my second
yeah.
question, Dr. Lakshmi, my second question
Yes,
is,
yes.
are the farmers able to operate this AI assistant system?
Yeah, this what we have done is like, we have extended to an app, and then we have asked them to develop. So they are able to read it. The numbers and all, they are okay. They just want to click initiate, start, all those things. So in that, the fertigation is found to be very much helpful.
Okay.
They know that the best crop is this one, so that part is okay, but the fertigation part was very lagging from the side. So we asked them like, you just use this app and see how it's going to work, and that was very much helpful for them. So
Okay. Thank you. Thank you,
yes,
Dr.
yes,
Lakshmi.
yes. Thank you, thank you.
Thank you. Yes, next, Aarti.
Yes, ma'am. Thank you so much for your presentation. Moving on to our next presentation. Dear presenter, please, I would request the presenter to present his paper on comparative study on hash algorithms. Dear presenter, could you please start with your presentation?
Sure. I hope my screen is fully shared. Please give me the confirmation when I'm audible.
Yes, yes, you're audible, sir, and your screen is also audible.
Thanks. So, first of all, good morning to all those who are present over here. And I would like to say thanks ISBM for accepting our paper. Our paper ID is 165, Comparative Study on Hash Algorithm, Kaishak MD, RIPE MD, and SHA Variants, authored by Pritesh Prajapati, Dr. Parth Shah, Devanshi Shah, and Rachit Shah. So our paper ID is 165. So why we have selected this particular paper versus this particular hashing algorithm comparison? So there recently we have seen very few researchers has worked on the hashing algorithm. So this is in continuation of our previous work, that is deduplication. And for that, we required to identify the duplicate files. And for that thing, the hashing is used. So in continuation of our previous works and previous papers, we identify several hashing families, and we have compared different 20 variants of this particular Kaishak MD, RIPE MD, and SHA variants. So briefly, this is the outline of our paper: introduction, related work, implementation, result, conclusion, future work, and references. So basically, what is hash? Those who are not knowing, just for them, a hash is a fixed digest, a fixed length string generated by the hashing algorithm, generally taking the input of any length and be creating a hash value of fixed message digest size. So ideally, it's uniquely representing the data. It's simplifying the task of like storage, retrieval, and verification. The main purpose of any kind of hashing algorithm generally varies to identify the data integrity, authenticity, and authorization for various applications like digital signature, password management, and to identify the duplicate files and so on. So what we have done, basically there are two types of hashing algorithms. So one is cryptographic and second is non-cryptographic. Generally, cryptographic hashing algorithms are designed for the security point of view. So there are three criteria for cryptographic hash: pre-image resistance, second pre-image resistance, and collision resistance. Right. So that is a part of the security. Now, apart from that, several values and several indexing algorithms are required. They are generally non-cryptographic algorithms. Generally, their task is to just identify whether this particular file or content is existing in the database or not. So generally, it is used in the indexing or searching algorithms to identify whether this file or this text or context or particular thing is present over that database or several other particular portion of that data storage. So security of the cryptographic hashing, right? So as I will discuss, hashing algorithm rigor is tested to resist different type of attack, that is pre-image, second pre-image, and collision resistance. So now MD5 and SHA1, they are considered as insecure because of this cracking of this thing. Actually, there is no cracking, but there is a backtrack kind of thing. Let's say if you are having that normal message, let's say message, and if you are doing that using the MD5 for hashing of that, so we're having the message plus hash of the message. So the attackers are having the list of keywords and they are calculating that hash value using any of the algorithm. And they are maintaining a dictionary for this particular task. Okay. So different algorithms are there. Recently, we are using, they're recommended by the NIST, that is SHA256 and SHA3. And generally, we use this applications in mobile and desktop. So in the thing, right? Cryptographic hashing are preferred in mobile and desktop. Now there are some concerns if you are using this particular hashing algorithm in mobile. If you are using in desktop, it will be totally working fine. But in the mobile, we are having the limited uh, resources, and we have to deal with particular battery consumptions also. So non-cryptography generally are used in that non-security related task, that is identifying that existence of that files or duplicate files and other or indexing, right? So different roles of the hashing algorithms are basically message authentication and data integrity are the main thing. And for storing the password, many of the developers are using hash of the message and they are there storing the password instead of storing directly in the plain text. So why we focus on this? Because in the blockchain also, right, RAM, time, and CPU utilization is required to having minimal resource requirement. So as per the particular reference number 128, we have seen that they have very earlier data and they have taken the experiments on that 10 to 5 to 10 years ago. Almost and several algorithms they have tested 10 to 15 years ago. And there is at that time there were efficient resources and other thing. Now we are having the capacity of exploring this algorithm, right? So that's the reason to in our existing work deduplication, we have used this particular concept. And this is only one of the module comparison of different hashing algorithm to identify the unique file. So these are the very basic introduction of the different hashing algorithms. So starting from 1991 to 2015, right, different families were there. That is MD, SHA, RIPE MD, Kazakh, and SHA3 family. So generally they are on the concept of sponge construction, where you'll be taking any bit random input, right? Any of the size, it could be 1 KB, it could be 1 GB, it could be 1 terabyte also. And it produces only fixed number of digest or fixed size of the output. Let's say 34 bits, 64 bits, 124 bits, right? It would be input will be any variable input, and but external output means final output will be only limited size, that is 128 bits or 264, whatever depends on the different hashing algorithm. So we have done the experimental study in this particular paper. We have compared 20 flavors of this particular MD family, SHA, RIPE MD, and Kazakh, right? And we have provided a comparative study kind of thing. So implementation, Java we have used, and the JVM on the backend. These are the processor and system type details. So for our testing, we have taken the text. So for this, we have created, because we don't have that text generally in a size, I think, having 1 GB. So what we have done, we have selected 1 KB to 1 GB of the data. Let's say 1 KB, 2 KB, 4 KB, and so on up to 1 GB. So we have created a random text using some existing algorithms, right? A random text for exactly size of 1 KB. Similarly, we have created the file size up to 1 GB. Images, we have taken the reference from the ISRO, one of the image having size of 1 GB. Then audio, similarly, we have recorded a video for one particular event, and we have converted that video to audio also. This way, we have collected the real world scenario. Now, after using the Java, we have exactly bifurcated this 1 GB file into different portions. That is 1 KB to 1 GB, right? So let's say text file, we have created 1 KB to 1 GB. Image files, again, 1 GB of the file we had. So we have bifurcated according to 1 KB to 1 GB. Audio similar way, and video similar, right? So what we identify the different data sets, and with this, we are going to present the average of everything. So time taken to process the file, RAM utilization, and CPU utilization of each algorithm. So for Kazakh, we have taken that version of 224256 and 384 and 512. MD, we have taken MD2, MD4, and MD5, RIPE MD, 128, 160, 256, and 320. And SHA, we have taken almost all that algorithms from the SHA family. So we are going to present in different 15 graphs. So we have compared 20 algorithms for this player audio, video, image, as well as text size, varying size from 1 KB to 1 GB. And we are presenting in the average form. So these are our results. CPU utilization of audio and text data set. So we identify that RIPE MD performs well in the case of audio data set. So these are the aggregate result of 1 KB to 1 GB. And for audio data set only. Similar way, text data for display hashing. So we can identify MD5 performs better and several other algorithms in the form of CPU utilization. Same way for particular image data set and video data set. There also we can identify MD2 is taking too much time, right, in the form of CPU utilization, then video data set. So the results are presented over here. Same way for audio, right? So we can identify that Kazakh and the RIPE MD performs well, even SHA3224 for the audio and text data set. Image data set, these are the RAM utilization. So let's say if we are concerning the case, taking the case of mobile, then we can select this RIPE MD or MD2, or else SHA3224, right? Similar way for video, we can refer this thing, right, for lowest and resources with concern to RAM. But it is identified that we cannot use that audio data set for MD2 algorithms. We're taking maximum time, right? So it's better to avoid whenever you are using the hashing of audio, we can use different algorithm compared to that MD. Same way for text. Because of the different nature of the algorithms, right? This particular algorithms plays a vital role at the time of doing the hash of this particular algorithm. Same way MD2, right? Time taken is very large, and MD2 again taking very large time for video data set. Taking less RAM, but taking time consumption is very high. Average CPU utilization. So what we have done, the average of aggregate of text, image, audio, and video. Now this will be representing in the form of all the data sets together, and these are the averages of the CPU utilization. CPU utilization as well as average RAM utilization in MB. So these are our results, and average time taken by the hashing algorithms. So again, here we can note that MD2 is taking maximum time. So at the end conclusion, KSAC is noted for superior based on the CPU utilization. So for resource constrained devices like IoT or mobile phone, we can use the KSAC due to 4. MD2 is taking the minimum RAM, let's say for lightweight mobile phone, if you are required to perform the hashing, then we can use this. But it will be taking the higher the plus CPU utilization, right? Then MD4 is used for efficient time consumption, right? Be advantage if you require time sensitive operations. Then MD5 is efficient, but it is having the vulnerabilities. It compromises that suitability of the application and requires the high securities, right? If you have other alternate security mechanisms should be there, right? So that's it about the future work, right? So it can be, we'll be utilizing this in one of the module of data deduplication, that is our existing work, and that can be integrated, right? And as of now, we have only compared 20 algorithms. In future, we are going to compare more hashing algorithm, crypto versus non-cryptographic hash algorithms also. So these are the references, but we have used only for this particular presentation. Yeah, thank you.
Yes, yes. Very, very nice presentation, Pritesh Kumar.
Thank you.
Yes, yes. What do you think? What are the drawbacks of whatever implementation you have carried out?
Can you repeat?
What are the drawbacks of your project?
Okay. So as of now, we have tested for this configuration only. Now we are going to test in various devices like mobile phone, IoT devices, and then we can come to the conclusion. Because this is the high-end processor. So Java implementation will be the same, right? We'll be converting this into that mobile application also. So as of now, from computing point of view, we have compared with the desktop only, right? But one can do that IoT devices and the real world mobile phones also. So that you can consider as of now the drawbacks.
Fine, fine. Thank you, Pritesh Kumar.
Yeah, thank you.
Thank you, sir. Thank you so much for your presentation. Moving on to our next presentation, we have our next presentation in the paper title, Enhancing Retail Success Using Machine Learning Based Media Mix Modeling, a study on developing markets. Dear presenter, could you please proceed with your presentation?
Yes, I hope everyone can see my screen.
Yes, yes.
Yes, it's visible.
Yeah, great. Research project is about the development of a media mix model for the retail industry using machine learning principles to be implemented in developing markets. So before I talk a bit about my research paper, it's important that I give a brief introduction about the retail industry as a whole. So the retail industry in a global scale is expected to grow at a compounded annual growth rate of 8.1%. And in the Asian region alone, China is the prominent retail player. And if we take the South Asian region, India has a bit more prominence than the other countries. And for this particular research study, I have only focused on the Sri Lankan context, as that's where I'm from. And the factors that I understood in the Sri Lankan context is it's a developing country. And when these countries are in a developing stage, there are factors that affect the businesses' operations in these countries, such as the cultural factors, the political instabilities, financial tensions, and higher economic downturns coupled with high inflationary rates. So there was a huge economic problem in Sri Lanka over the past 2 years, which kind of paved the pathway for this research paper. So with these high inflation rates in Sri Lanka, there was a huge political unrest as well. So because of these issues, many businesses had to either close down or drop their operations backwards or even cut down on their budget. And for some reason, most of the time when these companies are cutting down on their budgets, the ads would usually fall on the marketing budget. So because of that, many marketers fall into this case called marketer's dilemma. So what happens is in the modern day, you have so many marketing channels that you can work with. And these can vary from traditional channels to even digital channels. So when there are so many channels for marketers to work with, they need to decide which channels they should invest this very limited cut down budget on and which channels are not worth investing on. So that's where this media mix modeling kind of comes into play because it's able to measure the impact of certain media channels on sales so that marketers can decide which channels have the best impact and invest on those channels while disregarding the other channels. So it basically just answers the questions of what media channels are worth the effort and worth for the investment from this limited budget, and which media channels are not. So, with that in mind, the literature can be broken down into three main segments for this study. So, the first one is the use of random forest machine learning algorithm for the purpose of this modeling. So, up to now, most of this modeling was done using linear regression and classical linear approaches. But it was found out by many data scientists as well as pointed out by advertisers themselves that the linear model is not capable of recognizing nonlinear patterns and nonlinear was some research partners suggesting the use of non-parametric techniques. And therefore, for this purpose of this study, I have used the random forest machine learning algorithm. So when using the random forest machine learning algorithm, one of the drawbacks is it's very difficult to interpret the model itself because of its black box nature. So because of that, we have proposed the use of shape-free additive explanation values, which are calculations that can properly print out the proper interplay between media variables and its effect on sales. So with those two, I have also accompanied the adstock decay effect as well in the study. So the adstock decay effect is a pretty complicated concept, but to make it very simple for everyone to understand, let's say that you're watching television and you see an advertisement for Coca-Cola. And let's say right at the same moment, you see an advertisement on your Facebook application, a Facebook ad, for instance, on Coca-Cola itself. So maybe after 2-3 days, you might remember the advertisement you saw on your Facebook app, but you might not remember the advertisement you saw on the television. So the reason for that is the adstock effect. So it says that the remembrance when it comes to the Facebook advertisement was higher than the remembrance calculated for the TV itself because people remember the Facebook advertisement more. So there is a high adstock rate. So it basically calculates for how long a consumer will remember an advertisement in the back of their mind. So that can vary from channel to channel, from industry to industry, and can also vary from the company to company itself. So the research scope is kind of like this. So there are three main questions that I intended to answer from this research study, and that is the interplay between media variables, seasonal compositions like cultural holidays, and also economic factors because this is a developing market, and its effect on sales. And with that, I also wanted to look into the ad stock rate for each media channel for the advertising promotions, and also to ascertain how well the random forest was capable of modeling media mix modeling in this context. So the research data that I have used is in relation to the Sri Lankan context, and it was collected over the years of 2014 to 2020, and it relates only to the consumer electronics retail industry. So the features I've used are the TV GRP, which is called gross rating point. It's offered by the TV stations in themselves, and then radio spots, press exposure, meta impressions, Google search clicks, holidays, and consumer price index. So with that in mind, the methodology that I have used is pretty quite simple actually. So it starts with the data pre-processing, data cleaning, and then the time series decomposition, and then modeling using the random forest training and testing. using the cross-validation time series cross-validation on a rolling basis. As you can see, it basically uses an iterative approach where they train and test as it goes on the entire data set. And then we generated the sharp values. And together with that, we made the model predictions and generated the insights. So the insights were mainly focused on the prediction accuracy, seasonal effects, holiday effects, as well as the ad stock rates. So the results of the study were pretty straightforward. So as you can see from the time series decomposition, there's a major upward trend in sales. So that can be accompanied by the fact that there was a major digital adoption rate in Sri Lanka, rising adoption rate over those years. And therefore, it led to many consumers incorporating electronic devices in their households. So thus, there was an increase in the sales and demand for that. And as for the seasonal decomposition, you can see in certain months, there is an increase in sales. So in those months, it was recognized that those are the specific months where there are special offers for Sri Lankan holidays and cultural festivals, which is mostly accompanied by the gift giving culture in Sri Lanka. And as for the ad stock rates, it was recognized that the Google search clicks had the highest ad stock rate, meaning that further investments of this channel is good as there is a sustainable long-term effect from this channel. And as for TVGRP, it recorded the lowest ad stock rate, and therefore it's very good for these fast-paced commercials, which are not very long-lasting, maybe like a special promotion that is like very limited offers or something like that. And the can see that the mean absolute percentage error for this particular model is only at 4%. So which is very good as the bar for accuracy measurement when it comes to MAPE is usually 10%. So with that in mind, the model had a very good level of prediction. And as for the sharp values, it was recognized that meta impressions, season and TVGRP had like a pretty good higher impact on sales than other factors. And it was recognized that holidays have a negative impact on sales, which can be due to the fact that many of the businesses in Sri Lanka close down on holidays. So there could be a negative to understand in regards to press and take action, maybe change the content they put out and change their content strategy overall. So with those factors in mind, I can conclude this presentation by saying that this study provided the basic framework and the groundwork necessary for the analysis and development of media mix models in developing markets by factoring into account these socioeconomic and cultural benefits and well as factors. And also the model random forest itself proved to be very effective, which also provides the guidance necessary for future work in regards to non-parametric modeling. And also the incorporation of sharp values proved to be very effective as the results were in contrast to the similar to the right accurate environment in Sri Lanka. And also it provides the groundwork necessary for managers to optimize their media efforts and strategically plan for the months and years ahead. And it's recommended that this study be further explored because this study can provide businesses, regardless of their size, whether they are big or whether they are very small startups, to make use of their limited budget available and optimize it properly so that they spend money on channels that are worth investing on and that they're not wasting their budgets, which is a very important fact if you are a startup or you are a small business. So with that, I'd like to end my presentation and thank you all for joining. And now I'm open for the Q&A session.
Yes, very, very good, Jitama. Am I pronouncing your name correctly?
Yes, that's my second name. Yes.
Okay, fine. So your presentation was very nice, very interesting. And my question is that why the choice of random forest model for predicting the retail sales?
So from our research studies, and I also consulted with the marketing consultancy agency in Sri Lanka as well. I talked to them and they said that right now their approach is very linear as they are only using very simple linear regression mechanisms. So I started looking at some literature and there were several literature pointing out the fact that non-parametric models I thought of testing out random forest, extreme gradient boosting, both of the models. And from that, random forest performed better actually. So I wanted to base my research paper only on random forest. And for the extreme gradient boosting, I wanted to exploit further as there are different types of gradient boosting mechanisms. So that paper, I'm still working on that and set to be published. So that paper is on the backhand right now. But for the time being, I thought of using random forest as it's very capable of being fine-tuned and taking into context the nonlinear patterns in the data. So I thought it will be a good model for this particular research study as it's still a groundwork theory.
Yes, thank you. Thank you very much. And all the best for your next paper.
Thank you. Thank you so much.
Thank you. Thank you so much for your presentation. Moving on to our next presentation. The paper title for the next presentation would be Evolution and Advancement in ChatGPT, a Comprehensive Survey. Dear presenter, could you please start with your presentation?
Yes. Am I audible?
Yes, sir, you're audible.
Okay. And I think also my presentation is visible, right?
Yes, sir, it's visible.
Okay. So my research topic is evolution and the advancement in the ChatGPT, a comprehensive survey. So here actually we are focusing on doing the comprehensive survey for the existing ChatGPTs and their versions, and what exactly the outcome and the disadvantages that we found and what we can improve. And so because we are doing a comprehensive survey, so we have suggested few the research topics, the problem statements, and at the end of the PPT also. So this is my outline. First, I will discuss regarding the evolution of the ChatGPT and initial versions, then GPT-3 and what about the transitions to the GPT-4 and what are the limitations exist in the GPT-4. And then we also discuss the transformer architecture with the examples, so we can move forward with the regional language and their prediction and the text generation, and then finally conclusion and references. Okay. So here the conversational AI is reshaping the human-computer interactions, right? Because the most of the times the humans require the answers in the form of the human language, and it looks very similar to the human tone, because we just need to write the literatures and the literature review and the some content on the blog as well. So breakthrough like GPT and the bot have greatly improved language comprehension and response generation. And from 2018 to 2024, the lots of work has been done on this. So here are the simplified training flowchart for the GPT. Like we first do the model building, and then we required a pre-training with the lots of data. Either that data is in terms of the text or in the musical representation or any other form, right? And finally, we are doing the fine tuning on that, and further training is required to generate a more relevant predicted word after the existing word. Then our main objective is to provide a comprehensive survey of ChatGPT's evolution and capabilities and their impact, so we can suggest future problem statements for the PhD scholars and those who are doing the masters, and then examine its application across the industries. And we also explore that in which particular domain this particular research will be useful, and study seeks to offer a throughout overview of the ChatGPT's progress. So here, this is the history from 2018 to 2023. First, we have started from GPT, and over 110 million parameters is given actually for the natural language processing, enhancing to enhance the capacity of the natural language processing NLP. After that, in 2019, we come up with billions of parameters that is far better than the GPT-1. And here it is 150 billion parameters, which is capable to identify the long coherence of the sentences. And in 2020, the GPT-3 with 175 billion parameters comes into the picture, where the dramatic improvement in language understanding and generation is there. After that, the instruct GPT, that is the fine-tuned version of the reinforcement learning is there. And finally, we have the GPT-4. But here we have few limitations, but much better compared to the GPT-1. And here are also some examples given for the GPT-1 and GPT-2. And GPT-1 contains this kind of data generation. For example, we have the sentence, the cat sat on the, and the remaining sentence is unfilled or missing. So here the GPT-1 can suggest the cat sat on the mat. That is the next word prediction based on the probability and the interdependencies and the inputs that we have provided before to train the model. And this type of answers we are getting initially in 2018. But GPT-2 having the more parameters in billions, and this kind of improvement we just observed that right now if we write the in a Paralympic Games Paris 2024, India is, and the remaining sentence is if unfilled, the data is automatically generated in terms of paragraph, and the content is generated based on the last information they have. Right? So these are the key features, that 1.5 billion parameters are there, that is 10 cross larger than the GPT-1, but still improvements needed for the coherent and contextual accurate text generation. And ChatGPT-3 is having that kind of the improved story builder GPT, that we can say that, which is very much useful for the summarization and the translation purpose. And for that reason, and specifically for the domain NLP, this GPT-3 version is more useful. And here I have given the example that if we write the query something like this, can you write a short story about a dragon who learned to befriend humans? Then based on the context given and the information they have trained, we have given, it will create a comprehensive and in-detail story for us, right? So now we have the GPT-4, which having the vast applications where we can use this. GPT-4 is for finance, research, business operations, software, customer service, education, creativity, and healthcare. So here the basic transformer model architecture worked, and we have used this particular model to train our regional language, for example, Hindi and Gujarati, because I belong to the Gujarat state, and here it is very much needed that we work on this particular regional language. So before we go for the actual multilingual language and the statement creation, first we need to understand the attention. So here we have the one sentence in English, and we want to convert into a Hindi or Gujarati. So for that reason, an attention is required, that which particular word is having the more weightage, and what is the actual context of and the meaning of this particular sentence, right? Or even this can be a notes in the music piece and not only the text. So we can take the any form of data. So here we have two different categories, that one is encoder, and the second is the decoder. And both this particular transformer model architecture has the 6 encoder and the 6 decoder in the architecture, right? So here I have taken the example. If we are taking the input, the cat sat on the mat. So first we need to generate the tokenization, and similar thing that we are doing for our regional language as well. First we are creating the tokens, and then we are doing the word embedding for each and every particular character that shows the dependencies with each other. Right, so this captures the relationship and similarity between the word based on their meanings first, and then finally for each particular words we have created this particular embedding, and we are feeding this to a transformer network, and it looks like this, which have this encoder and decoder both, and all the words, all the tokenizations which have created the encoding be fed to the transformer model. But how this particular model understood that which particular character is having the more relation with the next other characters, and for that reason we require a positional encoding. In positional encoding, we have identified the weightage, and we are calculating the probability that what comes next after the the. And this will take the decision based on the previous data that we feed and the content we have given and the parameters we have fed to the model. And after that, doing this kind of thing, we then go to the input embedding, and we can go for the encoder, where actually the actual relationship and each particular word is having the query key and value kind of relation. And for every query of specific word and with the all other words, we just need to calculate this similarity score. And this similarity score will give you the probability that in the automatic content creation, what comes next after the each in specific word generated, right? And that is the main uh, heart of this particular GPT and its architecture. So these have the many capabilities, and a few limitations is also there. First, I talk about the limitations that it can produce the inaccurate or biased information, and careful monitoring is also needed, because sometimes it gives the wrong answers because we have provided the wrong input or the less data is available with us. And the advantage is it's also very good in creative writing and code generation. Even the literature review and the storytelling is also very much useful, right? And these are the future directions for which the master's students and the PhD students can work. That advanced method to detect the mitigate bias, and we can work on this. And also the enhanced data set is required if you want to work for the regional language like Gujarati and Hindi. That is the main focus of ours, and in future we are working on this. And also investigate methods to make the AI model like ChatGPT more explainable for other languages also. But main reason is we cannot access the real-time update, right? So this is the main limitations of GPT. For few queries, it will tell that we have only the data up to the 2023 January or June, and we don't have that much information. So we can improve upon this, and we are working on this. And also the user feedback integration, very much useful input from the users is also required. Sorry. So we have focused on specific applications, like we have old Grunts and Vedas with us, and few of the sentences are broken, or few pages are yellowish, and few data is not visible. So using this particular data, we can apply the OCR, and using the GPT integration, we can predict the next sentence from the sentences or the content available in the grunts, and we can complete the grunts after that, right? So we can reproduce the content using that. And for that reason, we have few challenges, and we will work on that. That is, multilingual training is required, translation and localization is also required, and focusing on the data availability and data creation. The the key input will be the data set creation for the regional language that we are actually working on, and effective model training and fine tuning. So this is the conclusion that, however, the GPTs are very much trained, and more accurate data is giving, but few challenges that we are facing, that the data sometimes creates the bias and knowledge limitations is there, and ongoing development and ethical considerations are crucial as the technology continues to evolve and reshape the human-computer interaction across the diverse application, right? And these are the references that we use for our survey, for our research, and for this particular presentation and research work.
Yes, Dr. Sanket, very
Yes.
good literature for the evolution of ChatGPT. And have you tried it for the prompt engineering?
Yes, ma'am. We have just started doing on working on that, but first we are focusing. Our limitation is that we have very limited data, specifically for the our regional language, right? So, and also this particular language that we are focusing on is Hindi and Gujarati, but Gujarati is more complicated because they have connections, joint characters, Kano, Matra, Shwe, Dege, that is the modifiers are also present, and for that reason, first we are focusing on the data set creation. But the more effective data we have, and the more accurate training that we can provide to them.
I think OCR can help you, optical
Yes,
character
yes.
recognition.
Right,
Yes.
right. So we have
Yes.
created the individual words data set as well as the characters with the modifiers and the isolated characters. And now we are applying this particular model on our regional language, so we can have the automatic data generation, sentence recognition over there.
Yes. Thank you. Thank you very much.
Thank you.
Thank you, sir. Thank you so much for your presentation. Moving to our next presentation, we have Green Hub, Analytics and Recognition for Healthcare Solutions. Dear presenter, could you please start with your presentation? Dear presenter, are you there? Okay. So this is the last call for this paper, Green Hub, Analytics and Recognition for Healthcare Solutions. Okay. So that brings us to the end of our presentations. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was very informative enough. We, on behalf of the whole team, thank you for the support during this third version and all the previous two versions of the conference. We would be happy to have you in the fourth version as well in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have been forwarded to Springer. The publication would be live within 6 months. Kindly cooperate with the team of ISBM 2024. I also thank our session chair, Dr. Varsha ma'am, for chairing the session.
Thank you. Thank you, Aarti.
Thank you, ma'am.
And
We would be very happy to have your feedback and wishes for our participants.
yes, yes. From earlier, I have been the session chair many times for this conference, and my experience and also the today's experiences, like the research work, everyone is doing excellent in the research work, and the presentations were also very nice. The cooperation of the team members, giving reminders to me from time to time, it's an excellent work. At the same time, I would also like to thank Dr. Amit, Dr. Nilanjan sir, and the program chair of ISBM for inviting me as the session chair for the conference. Thank you. Thank you very much.
Thank you, ma'am. Thank you so much for your valuable words and feedback. So I would kindly request all of you to please switch on your camera so that we can have a quick snapshot of our virtual conference. Thank you. Thank you so much. Take care. Stay safe.
Thank you.